So in this video I'm going to integrate 10 over e to the x minus 2 from 1 to 6 with regards to x. Now to get this integral there's more than one technique. Now I recommend you pause the video, have a go yourself, and I'd be interested in the method that you guys use to solve this integral. So now I'm going to show you the technique that I would like to use for this particular style of integral. Now I do a U-substitution of the whole of the denominator in this case. So then I've got u equals e to the x minus 2, and then from there I need my du and I need to change my parameters, and that's how I like to go about doing my u substitutions. So now I've got du equals e to the x dx, and then get my dx on its own, which is du over e to the x. Now e to the x here is not going to cancel with anything in my numerator. So I need to just adjust this e to the x a little bit. Now what is e to the x in terms of u? Well, if u is e to the x minus 2, then e to the x is u plus 2. So I'm just going to just change that in terms of u. So now dx equals du over u plus 2. So that takes care of that. And then now I've got to deal with my parameters, because these are the parameters in terms of x, but I want to change everything into terms of u. So if x equals 1, then u equals e to the power of 1 minus 2. So I just write it as e minus 2. And then if x is 6, then I've got u equals e to the 6 minus 2. So that takes care of my parameters. Now I can just put all that in and let's see what we're left with. So now lower parameter x equals 1, so I've got e minus 2, so that's for my u. And then my upper parameter, I've got u equals e to the 6 minus 2. So I'm going to write that in there like that. So that takes care of that. And then here I've got 10, which I'm going to bring out to the front. And then so I'm left with a 1. Then e to the x minus 2 is just my u. And then my du, I've got u plus 2 in the denominator, so that's my dx replaced with all of that. So now I've got du and then u plus 2. Okay, so now I've got 1 over u times u plus 2. So now I've got a partial fraction decomposition situation. So now let's just set this integral up ready to try and work that out. So now I've got e minus 2, e to the 6 minus 2. So then with my partial fractions, I'm going to need two constants. So I've got a over u plus b over u plus 2. And then I've got my du at the end. So now I've got a couple of constants I need to find for my partial fractions. So let's just do a quick cover-up method. So I'm going to get that with these separated. So now if I plug in u equals 0, into that, I get 1, cover that one up, over 2, so that's a half. So a is a half. And then for this one to cover up, I need u to be minus 2, so that will be covered up. 1 over minus 2 gives me minus a half. So that's my partial fractions taken care of nice and speedily with the cover-up method. So now let's rewrite it with that result. So 10 e minus 2 e to the 6 minus 2 1 half. So I'm going to just write that in the top there because I want to leave my 1 u on the bottom in the denominator. So 1 half over u minus, so I change that to minus, and then b is a half again. So they're going to go a half over u plus 2 this time, and then du for all of that. So now these will all just become natural logs when I integrate them. So let's just integrate them straight off with a constant of a half, which I can then take out. So that half comes out, and then just divide this by 2, and they just cancel out. So I'm just left with 1s. So that's making a nice little bit of a simplification there. So 1 over u minus 1 over u plus 2. So now I've got 5. Now let's calculate what I've got here. I've got ln of u. Now do I need my absolute value? Well, my lower parameter is greater than 0 and my upper parameter is greater than 0. So I can just leave this as just brackets without the absolute value. So now I've got log of u minus log of u plus 2. So that can be taken care of there. So let's just put that one in a bracket as well so it's nice and clear. And then that's calculated from e minus 2 to e to the 6 minus 2. Remember, that's not in our indice. Okay, right. Let's simplify this off. So now I've got upper parameter, ln of u minus ln of u plus 2. So where I see a u, I put e to the 6 minus 2. So I've got ln of e to the 6 minus 2, ln, and then I've got e to the 6 minus 2 plus 2, just gives me ln of e to the 6. So there'll be a nice simplification coming there. So that takes care of that. And then subtract my lower bound. So ln of u, so that's ln of e minus 2. And subtract that from ln of u plus 2, which will just give me ln of e. So that becomes minus ln of e. And just being careful here with minus signs, because I've got two there together. Okay, now let's clear some space off the board and let's finish off our value for our integral. Okay, so now I've got the integral here so far, so I need to do some simplifications. So that, I'm not going to touch that, minus ln e to the 6, so this just becomes a 6, so that's a 6. Then I've got ln of e, well that just becomes a 1, so that takes care of that. And then I've got ln of e to the 6 minus 2 minus ln of e to the minus 2. So when I've got two logs which are subtracted, I can then combine them into a fraction. So let's do that, and let's distribute this 5 with it as well. So now I've got 5 times natural log, let's open up a bracket, e to the 6 minus 2 over e minus 2. So that would take care of that. And then I've got 5 times minus 6 minus 1, so that becomes a plus 1, so that becomes minus 5. Times that by 5, I've got minus 25. Okay, now I've plugged that into your calculator, you'll get approximately around about 6.6 and a few bits. Okay, right, that completes this integral. So thanks for watching.